Hello guys, a very happy morning to any one of you, and from this video we'll just going to start the next series of the fluid mechanics. And without wasting any time, let us get started. In the previous video I just mentioned about the Newtonian fluid, non-Newtonian fluid and a little bit of the ideal fluid. In today's video we are just going to see about the surface tension. So what is the meaning of surface tension and how this surface tension helps the entire fluid mechanics, and we're also going to see a lot of other things about the surface tension. Okay guys, without wasting time, let us get started. See guys, suppose surface tension means it's so much simple. So without it means especially drawing there, I'll just explain in this picture itself. So this is the entire water body. It means water molecules. You just consider. So each and every time the water, little bit of water molecule has H2 will be the present in each and every sector. So each and everything will be so much balanced. See, you can see here guys, as it is completely balanced. So lot of molecules will be present around it. So while there are molecules, it means here it will be there. But it means the molecules that are being present in the outside of the layer will be in a unbalanced way. It means an unbalanced cohesion. So cohesion means, as I told you, about the attraction of the two molecules. So this A molecule attracts the B, this molecule attracts the A. So and simultaneously you can see this B molecule also attracts the C. It means this B molecule attracts the C molecule to come inwards. So while this is being attracted towards inwards, what it will do means, suppose you can see this is my hand. So in my hand, as I'm just pulling, lot of, you can see the skin is coming. But when I just tied it down, suppose you just consider this is a B. It means this is a B is pulling. So B is pulled, and now you just pull the skin. So now the skin is coming. You just try within your hand. The skin won't come. So like that kind of thing, that while we are just compressing our hand, this B molecule tend to attract this kind of C molecule towards inward. So that's why this kind of area becomes so much stretched. You cannot. It means from here it will be so soft. It means you can see like this, the skin will come upside and a lot of things. It means it will be so soft. But you just see now you cannot. It means you can't picture the skin will become so much rougher. So that's called the surface tension. So due to unbalanced cohesion, they will be pulling of surface molecule to inside. So on all sides, so from the maximum, you can see from the maximum condition, from the maximum area, it tends to form the minimum. So now minimum area. So I think so you got my point. So in this I think we have mentioned, as molecules A and B having balanced cohesion, so as A and B having balanced cohesion, and the C will have unbalanced cohesion. Due to unbalanced cohesion, liquid surface tends to contract towards the interior until the surface area becomes minimum. Okay. So we can feel the surface behave like a membrane under tension. So now what will happen here? The tensile force will act. Tensile force means, as usual, you can see this kind of thing outside. So lot of tensile force will be act. So and each and everything acts normal to the line run. It means each and everything there acts normal to the line run. So I just shown in the front view. When you see in the top view, how this is the top view and this is the front view. So I just it means I think so you can understand. So surface tension force acts normal to the line run on the surface and along the plane on the surface. I think so you got my, it means you understood the point. The characteristic of surface tension force: one is tensile in nature, normal to the line run along the plane of the interface. So these are the little bit of extra thing that about the surface tension, and the main formula comes under this. You can see surface tension force per unit length is called a surface tension. So sigma equal to surface tension force per unit length. Okay, sigma equal to surface tension force per unit length. So the next thing is, so this is the basic formula. So surface tension equal to surface tension force divided by length. So for force, what is the unit? Newton per meter. So you can say Newton per meter. So Newton can be also written as joule per meter. Joule per meter equal to Newton. So okay, and this meter can be also gone down. So meter square will become. So for force, mLt power minus 2, and for length it's been given as cell. So surface tension is, what is the dimension? T power minus 2. So this is the most important question that will ask in a lot of HAL, a little bit of ISROs, and a lot of other competitive exams. So this question won't be asked in the most of the gate, but this will be asked in other private exam. So okay, why the surface tension occurs? There are two main reasons. One, the surface tension occurs due to the cohesion. It means due to the unbalanced force. And second thing, the interface. It means because it been exposed. So if in this two things, if any one of the thing is missed, means the entire, it means the entire surface tension force won't come. So as surface tension, it means surface tension comes due to the surface tension force. It comes due to the interface between the stretched membrane. You can see the interface between the stretched, here the stretched membrane. So the interface has been, it means it's been present as a layer, and because of the minimum, it means now it forms the minimum surface area. So because of this, a lot of contraction will occur, and the unbalanced, it means as the B molecules tend to pull the C molecule, a lot of unbalanced cohesion will be occurred. So that's why this kind of surface tension is occurring. Suppose if you see a lot of mosquitoes would have been sitting on the, especially in the water area. So because of this, as this area becomes so much stretched, lot of pressure will be, it means you can easily sit here because this surface is entirely in a surface tension way. So the mosquito can easily sit here. Suppose if it is relaxed way, means if the B molecule doesn't attract the C molecule, means then directly when a mosquito comes and sit in the water surface, it will directly sink. So as B molecule tend to attract this C molecule, it means this C molecule towards inward. So that way the entire stretch, it means the entire area is called, it means stretched way. So that's why the mosquito has a capacity to sit freely in the above the water surface. So what is the in the interview they will ask what are the examples of the zero surface tension. So one thing is you can see about the critical point. So the critical point here, there is no distinction between liquid and vapor, because for each and everything there should be a difference, because if there is a girl there should be a boy, so this little bit of difference should be. So as in critical point there is no difference between liquid and vapor, so that's why there is a no zero. It means the surface tension force at the point is a zero. So I think so you got my point. So other thing guys, suppose when you, it means suppose if your cloth is so much dirty, so what the most of the mothers will do, they will just put the cloth in the washing machine, and sometimes they used to turn on the warm water and little bit of detergent they will just add. So why this warm water has been adding, and simultaneously why this detergent has been adding, especially why we can't just wash the clothes within our empty hand, within our hand. So why we need to add a bit of soap or a bit of detergent and warm water, hot water to them, because the temperature increases. It means while the temperature increases, the cohesion decreases. It means the attraction of the two molecules decreases. So while this is being decreased, the unbalanced cohesion decreases, surface tension also decreases. So that's why while we are just adding, it means the washing powder, the detergent powder, the detergent liquid, while we are adding, the cohesion of the water molecule tend to decrease, and alongside with the so that it means the fluid has a easy capability to penetrate deep into the water. It means deep into the each and every particles that been in the cloths. So now as it goes into deep into it, now it can clear, it means now we can wash the easily of the lot of dirty cloths has been there. So see, warm water has low surface tension, so it can penetrate the cloth and removes the dust particle easily. So while adding detergent to the water, it reduces the surface tension in the water, so that's why it has so much easy capability to penetrate and to clean the entire cloth. So suppose if we take about sea water or normal water, suppose while you just rinse with the normal water, it cleans the each and everything. But if you take the sea water and you just clean, definitely none of the thing will be cleaned. So the other thing is, on increase in temperature, cohesion decreases, leads to decrease in the surface tension. So warm water used to cleaning the cloth, since surface tension is less for warm water and can penetrate easily the small opening between the fibers for effective washing. I think so you are getting and you are catching the point. So surfactants, soaps and detergent reduces the surface tension of the water and air interface, where salt as the NaCl increases the surface tension of the water. So that's why this kind of thing is not been added. Suppose guys, whenever the people used to spray the mosquito spray, you can see white means white layer of the, it means white smoke would have been emerged. The white smoke mainly consists of kerosene. While the kerosene is being spread over there, the water has a capability to absorb the kerosene within the water itself. So and adding kerosene to the water, surface tension of the water air interface decreases. So while it is been decreased means, okay, while this has been decreased, it means especially the mosquito has the easy capability to go inside the water, and it will just directly die as it is. So that's why this kind of kerosene is been added. So you can see about this, it means this kind of other thing, just leave it. And surface tension force depends on the two major things. One is liquid as well as gas. So downside is a liquid and other side is a gas. So if this is kind of liquid droplet, means this liquid droplet around the gas will be there. So surface tension mainly depends on the two things. One is liquid and as well as the gas. Okay, this one, okay, we can just go to the next one. You can see the surface tension force of the water and air, and hydrogen, it means mercury and the air, and soap oil and the air. So these are the other kind of thing that we just need to talk about the surface tension. See, as I told before, like it means the water, it means the surface tension of cohesion and as well as the adhesion. It means on the liquid and as well as the gas. It means whenever you just suppose this is liquid, here the unbalanced cohesion will be, here the balanced cohesion will be. Each and every time this B molecule will attract the C molecule towards inside. So I think so you are getting my point and catching the point. So this, it means this unbalanced cohesion, where it will interact? It will interact with the air. So this unbalanced cohesion will have an interaction with the air. So this and down, it means unbalanced top surface will have the interaction with the air, and the bottom surface will have the interaction with the water. It's the bottom B water. It means, I think so you got my point. So we need, for surface tension we need both of the properties, about the water properties as well as the air properties. So at 20 degrees Celsius 0.073 Newton meter of surface tension will be. So you can see when we have just the mercury and the air, you can see 20 degrees Celsius mercury unbalanced coefficient is so much high because mercury has so much tendency to attack towards each other. So I will just show you something so you can have a better understanding. Mercury coefficient COC force, okay. See, now you can see here. See how the mercury is there. It means it has a opposite way. You can see here the blood is in a downward bending force, but here mercury is in upward. So the mercury coefficient will be so much higher. You can see here the mercury coefficient is so much higher. But when you can just compare with the water will just spread all over the area. But you can see here the mercury coefficient is so much higher. So you can see. So I think you are watching the point. So you can just go to the next one. Next is so see, as the mercury and air has so much of surface tension. The other thing is you can see as the surface tension, what I just mentioned in the formula, surface tension equal to surface tension force divided by unit length, okay. So surface tension force per unit length, and we could have measured the surface tension. It means how much the force is acting on it, okay. It means very small, and as you compare to the yes. The other thing is there are a lot of force around the entire universe. It means the gravitational force is there, and the cohesive force. It means the shear force is there, and viscous force is there, and all of the most compressible force is there. But when you compare with a lot of other kind of force, the surface tension force is so much lesser. For example, gravity force. You don't know about gravity force and compressibility force, shear force, and tensile force, and a lot of other forces has been there. It means viscous force. Maybe 6 to 7 forces are there. But when you compare with all of these force, the surface tension force is so much lesser. It means 0.001, so much lesser. So that way we generally neglect a lot of the fluid mechanics problem. So I think so you are catching the point. The next thing is we can just see the surface tension value. As the surface tension value is so much more, so we study in the fluid dynamics. We just neglect it. Okay, it means small insects, mosquito and water riders sit over the water due to surface tension. And also leaf, it means leaves float over the water, this also due to surface tension. And small needle, that also sometimes float. It means generally, I'll just show you some. So and it means small needle. So you can see here guys, as the needle is it means floating over the water. So you can see, it means you can see here the little bit of needle is, these are very able to see here, see lot of needles is been floating over the water. So this will become surface tension, and surface tension is also used in the clinical testing of jaundice also. So you can see here the surface tension acts due to unbalanced cohesion. One is cohesion and next one is the interface. Interface is liquid and gas. So if addition is given, means you have to just notice around the question what kind of addition is given. Mostly the interference must be needed for the surface tension. So during the normal testing of jaundice, what they will do, it means they will just suppose for example they will take the urine sample of the jaundice patient, and some kind of sulfur powder is placed upon over the urine sample of the jaundice person. Suppose if it is normal urine, means sulfur will float as it is. But if it is the person has jaundice, means the sulfur will directly sink over it, because this doesn't have a lot of surface tension. You can see here guys, normal urine and the air, it can 65 dyne per centimeter. So it has a little bit of extra surface tension. But you can see while the bile salt, jaundice patient, when the air interaction, it has only 55. So the surface tension is so much lesser, so it can't able to hold the sulfur upon it. So that's why the sulfur able to, it sinks. So this is called as Haas test. So suppose in the interview if they ask this kind of question, you can just lightly mention this. So the next thing is, you can see the gauge pressure inside liquid droplet. You can see guys, each and every time the liquid droplet, suppose for example, wait, I'll just show you liquid droplet. See, now you can see here why this kind of liquid droplet is been occurring. Because due to the surface tension. Why this kind of spherical shape and why this kind of round shape and each and everything is there? Because of the surface tension. So you can see here the inside is concave. It means the inside is concave and the outside we can see it's convex. So it means from inside to outer like this we will see, from outer to inside like this we will see. So the surrounding, it means the entire surrounding is being placed upon by, it means P atmosphere. So and the air is outside, and so see from inside there is a concave. It means from inside we see outside means it's convex, from outside we see inside means it's a convex. So inner side the pressure will be more. and the outer side the pressure will be less. So it means inner side, suppose guys, for example, but it is in a balanced way. For example, inner side is 1.5 atmosphere and outside is 1.1, means directly this liquid itself won't be. So the inner side will be have a tendency of more pressure to expand, but the outer side will try to compress it. So the both of the pressure will be equal. But when you compare with that logically, the inner side pressure will be more and the outside pressure will be little bit lesser. So I think so you are getting my point. So the P, it means the P will be higher and compared to the P atmosphere. So it means what the thing is, now you can see the inner side we have, it means we just slice, it means as we just cut the ball into two pieces, as we are going to cut the, it means what is suppose water droplet shape cut. Right, let us see it is coming or not. Okay, I think so it's not coming. Okay, so what we are just going to do, we are just cut over the two surface. So like this we are just cutting the two surface. So what will happen, there are a lot of surface tension force will act on, it means will act upon the surface. I think so this one thing is the surface and another side is the inside pressure also, it means the inner area also will act. So one is the joining force, it means one is joining, another one is a bursting. It means this side, it means as the surface is being done, this is a joining force and the inside one will be the bursting force. So now bursting force equal to joining force. Okay, so what is the formula for force? It means pressure equal to force by unit area. So force equal to pressure of into area. So I think so we are catching the point. So now what we are just going is, one thing is acting out on surface tension and other thing is inside the pressure will be pressure PG, gauge pressure will be, and the other thing is surface tension. So surface tension force, you just don't consider my handwriting, and equal to, it means the bursting force. Bursting force comes due to the pressure and surface tension force gives to the surface tension. So what is the units of surface tension? Equal to surface tension force divided by length. So FST equal to sigma into L. Okay, I think you are catching my point. And the next thing is, you can see the bursting force equal to force equal to pressure into area. So what is the pressure? PG, gauge pressure, into what is the area? It means inside area, pi by 4 t square. Okay, so length, how you can just it means how you can just note down this length, pi into d. Okay, or 2 pi r, it means length. For example, how to say, wait, I'm not getting anything. Okay, let us example. You can see here guys. Okay, for example, let us see ahead. So I'll just measure, this is how much it comes. It comes to 12 centimeter this side, and this side I'll just measure 12, this side 8 centimeter is coming. Okay, this 8 centimeter plus 12, 20 centimeter. So while just keeping the round, it means while I'm just compressing, if you measure this kind of each and everything round, means it will come as 20 centimeter. Okay, I'm just measuring this and this. So while you just measure this, it will come 20 centimeter. So that's why this kind of radius is taken. If suppose this kind of radius is given, it comes around 3 meter, 3 something, more than 3 meters come. So you can see the radius comes around 3 meter. My camera quality is not this much good. Okay, let's see. So length equal to 2 into 3.14 into 3 meter, so 3 centimeter. You just make a multiply, 3 into 3, 9, and 9 into 2 comes around 18. So 18 point something, it means goes to 19. So the length, okay, I think you are getting my point. So now sigma into pi d equal to pg into pi by 4 d square. So now what will be the gauge pressure? So d cut, pi cut. So sigma equal to pg divided by 4 into d. So pg equal to 4 sigma by d. So for water, so water, the gauge pressure is this one. Okay, I think so you are getting my point. So 4 sigma per d. Okay, I think so you are catching the point or getting it quickly. So the surface tension force will be normal to the line. So the next thing we can just see. So this thing I will just explain in the, it means the third chapter. So it is one of the most important thing. So what is the, it means as we are just going down, the pressure will be so much higher. So here what is being given means the bubble is placed deep into the water. So I'll just bubble deep in the water. Okay, see, you can see here guys, now you can see here little bit of bubbles is there. Okay, the bubbles is there. So what we are just doing is, from here, let me mention here the surface, it means the surface is here, and from there to here we are just going to come. So bubble, so here the pressure will be, it means pressure equal to rho GH. So this pressure will be, and simultaneously P dash. So this is a, It means air bubble for gauge pressure of air bubble equal to 2 sigma by d. So here it's a water bubble means Pg equal to 4 sigma by d. And what is the total pressure? This total pressure P equal to this 4 sigma by d plus of rho gh. Okay, this is the water. So if air means P equal to Pg, it means 2 sigma by d plus of rho gh. I think so you are catching the point so much quickly. So this is the formula that's been given here. So we have to just consider each and every part. So here the soap bubble is given. So for soap bubble, no need lot of complication, but you can directly remember over the formula. For soap bubble, Pg equal to 8 sigma per d. Okay. So you can see here guys, for spherical it means, for the, as I just showed about the water, is about 4 sigma by d, and for spherical it means as it consists of water, it means soap bubble means you suppose soap bubble. Yes, so you can see this is the soap bubble. So generally soap bubble do consist of 2 layers. Okay, you can see. Okay, generally soap bubble, what is it has 2 layers like this. So two surface tension force acting. One is outside surface tension force, another was the inside surface tension. I'll just like this. Okay, here is one is acting here outside, and next one the inner side is acting. Okay, I think so you're getting my point. So 2 surface tension force outer plus of inner equal to bursting force. Okay, if you just equate this kind of two things, you will just add the right line. You can see this is the formula, and if you just put it down, and here the each and everything will come back on to you. So as the d minus d, it means as the diameter is so much lesser, so we will just combine to each other. So the soap bubble 8 sigma per d. Okay, that's the surface tension force. I think you are getting. And the next is the page pressure for liquid jet. So liquid jet, come on. So this is a liquid jet. Okay, I think so you're getting. So this is a liquid jet. For this, how much the surface tension force will be? That is so much simple. It's 2 sigma per d. Okay, for the liquid jet, it is 2 sigma per d. As I just told about in this case scenario, it's about this is a gauge pressure for liquid jet. Suppose here the liquid jet is at 9 instead of air bubble, the liquid jet. Here suppose any kind of water bubble or any kind of soap bubble is there, means 8 sigma per d. So for liquid jet, it's 2 sigma per d. I think so you're getting my point. So in this thing, you can see here guys, for this the liquid jet will be, it means here the opening will be, and here liquid jet will be. So when we just like this, and if you just cut down means what will be here like this. Okay, so here surface tension force, and when you just put in the opposite way here like this, what here will be the bursting force. So surface tension force and equal to bursting force. So this is the bursting force, and the next is joining force. You have to just write, it means this is L, this is L. So that's why it is given as 2L, and here the bursting force will be there. So you need to just combine over each and everything. So letter Pg equal to 2 sigma per d it will come. So I think so we are getting my point and catching the point. So the next thing is surface energy. So what is the meaning of surface energy? So guys, it is surface energy. Okay, you can see here guys the surface energy. So you can see droplet of water in a, it means this is low surface energy, and you can see here the droplet of water, this is high surface energy. While you can see the as a low surface energy is contained, it usually releases in an expanded way. While it means high surface energy, it goes to the ground. It means that it is so much stick to the grounded surface. I think so we're getting. So you can see this is called a surface energy. So how the surface energy is comes under, you can see here to each and everything. So this also comes under the gap, it means potential of the surface energy. So how the surface energy is coming, and there I have just it means they have just given in a smaller format. So one thing guys, you can just see this is it means we will just take a newspaper so I can have a better and clear understanding to you. So I think so this is a ball, you just consider this is a ball, and here the surface tension, here one particle is there. So what I am just doing is, I am suppose in this thing you can see only smaller thing is there and a smaller location, it means at a smaller area. But when you just expand it, you just see it goes somewhere. So before it was in a here, But now while it is going, it is expanding in other way. It means goes to a little bit of larger surface. So that's why it is being saying it. So initial the two of the thing is that as we are just touching it, this two particle goes towards this. So that's why it's called as surface tension. It means surface energy. So initially assume the crust paper. It means it consists less number of molecules. While we are just giving a lot of energy, a lot of things, the molecules also tend to increase so much in a higher way. So the crust paper to the normal paper for just an example. So during stretching of an interface, work is done to move liquid molecule from the interior part to the surface against the attraction force of the other liquid molecules. I think so you are getting my point. So here each and every time, suppose see here the molecules is there and here also the molecule. Oh wow, this is a good thing. So you can see. So here each and every molecule is there, but while we are just expanding, what will happen? This molecule goes through the outer port. So we are just applying a lot of energy to it. So that's why the molecules neglect the attraction of each other, each and every molecules inside the each other. While we are just applying out external pressure, this molecule tend to go outside, breaking of the other two remaining molecules. I think you are catching my point. For example, this is A, this is B. Both of them having a good interaction with each other. While a third person comes and disturbs them, these two molecules go out. So that's why the third person is called as energy that tends to move this A and B particle from the inside. So the work is done. So as we are just giving the energy, the work is done is stored as potential energy of the molecule available on the surface. Potential energy of the molecule on the on the interface is known as surface energy. Okay, I think so you are getting my point. And one of the other important thing is the work done in stretching. It means while we are just giving the energy, it is converted to the work. See guys, potential energy and work is little bit same thing, but the units are different, because for energy it comes on joule and for work done it comes on Newton per meter. So joule per meter, Newton per meter, like that it will come. So I think so you are getting my point. So this is a small basic example, but we don't need this kind of lot of explanation. We can just directly go to the formula, because this it means this formula is mostly asked in the it means GATE and ISROs also. See, and one thing, this surface energy for it means this formula is also asked in one of the ISRO exams. And you can see this is a little bit of thing. Suppose for example, for example, take this as a piston, and what we are just doing is here the molecules will be, we are just making to come to our outer surface. So it been stretched. So it may have been stretched to a little bit of x distance. Here x and here delta x. It will change the distance. So at the beginning, what will do? A1 equal to 2lx, and A2 it means as the area is changed, it means 2l x plus of del x. So I think so you are getting. So next thing is the change in L will be each and everything. So this I think so. This is not that much needed. Okay. For example, work done, it means what is our unit of work? Force into A, it means distance. So force work done equal to force into this, it means del x amount of distance we have just changed from 1 to 2. So del x. Okay. Here the surface tension force is also being acting. So that's why what we are just giving, F equal to sigma into length, and del x equal to what will come? Del x. So work done equal to the surface tension force, so sigma into 2l into del x. So okay, why this 2l is coming? You just make this into, this is a front view, we just make it into the 3D view. So this one L will just take, and this one L will just take. So for the length, as it consists of 2L, it means 2 times of length. So that's why this is kind of 2L. So what is equal to sigma into, it means as this consists of the whole area. Okay, this as the distance is also changing, del x from here to here, del x as we just consider, so delta into area. So what done equal to surface tension force into change of area. It means as we are just changing the x, we are just integrating with the del x. I think so you are getting my point. So increase in surface change means this thing fully is increase in surface area. Okay, I think so you are getting the point. And the next thing is, you can just see here guys, where it is. Okay, so this is a change in it means increase in surface energy, as 1 it is 1 and here it is 2. So it is increase in surface energy as we are just changing. So we have just means minus of it means before area and after area. So we can directly just see this kind of lot and other things is not needed, because from 1 point to next point they are just changing, that's it. So it's a general formula, this one. So then a basic formula is energy equal to sigma, it means surface energy into area. Okay, so the surface energy can be defined as surface tension. It means surface tension can be defined as, this surface tension can be defined as surface energy per unit area. Surface tension equal to surface energy. Suppose if they ask two kind of definition, means surface tension equal to surface tension force per unit area of length. It means unit length. And the next thing is surface tension equal to surface energy force divided by area. This is surface energy. This is area. I think so you are getting my point. Suppose for the area equal to 1 meter square, means surface tension equal to surface energy force, surface energy per unit area. Okay, surface tension can be defined as surface energy per unit area. So sometimes in the interview also they might ask, okay, suppose your name is Shah Rukh Khan. Your name is Shah Rukh Khan, means okay, Shah Rukh Khan, you are just came for the ISRO and DRDO interview. Why the raindrop is always spherical? Because I will just show it to you. So you can see the raindrop is mostly spherical in shape. Okay, see, wow, this is a beautiful image. This one, I'm just going okay, why this is kind of spherical in shape? You can see here, guys, this kind of rain droplet is so much spherical in shape. Why this kind of thing is occurring, Shah Rukh Khan? Please tell me your answer. Sir, I don't know. Say, you just get out of the room. I just will sit. So what the main thing is, it means the rain drop is spherical because it has a minimum surface area. As it has minimum surface area, it has maximum stability, and it means as see, as it has minimum surface area, for it's, guys, this is so much simple. Rain droplet is in spherical as it has minimum surface area. It has higher maximum stability and minimum energy. So as the energy is minimum, it means as the minimum for the, it means surface area for the rain droplet is minimum, so it leads to the minimum surface energy and as well as maximum stability. So that's why this rain droplet is so much stable in structure. So surface energy equal to surface energy for surface energy divided by area. Okay, you can see. So as the area is minimum, this energy is also minimum. So sigma area equal to EF. As area is lesser, the surface energy is also lesser. Okay, so but stability will be maximum. So that's why in the last of the table, it means you can see the most of the, it means spacecraft, the hull will be like this. One mostly it will be in a spherical shape because it has a maximum stability. Wait, I'll just show you to space. Dome spacecraft. What is this? Okay, this is one type of other spacecraft. Imagine it's a spacecraft which is concerned. This kind of spherical thing is maximum stability with one whole only minimum energy, but it can be remain so much stable, guys. So that's why this kind of spherical is being mentioned here. So next thing is, it's also one of the important formulas that you have to just note it down. So what is the unit of work done when we just relate with the surface tension? Work done equal to surface tension into change of area. So this is most of the important formula. Work done equal to surface tension into of change of area. So what here is doing is, in the question they will ask, it means one question, this is a meter of 5 meter. Of what I'm just doing is, I'm just converting into lot of n number of particles, n number of molecules, n number of drops of 0.1 meter of radius. So you can see R1 equal to 5 meter, here R2 equal to 0.1 meter. So literally I'm just converting one droplet into 1000 droplet of 0.1 meter of radius. Here 0.1, here 5 meter of radius is there. So how we can just convert it? So but you can see, guys, the volume is both of same. So here volume equal to 5 meter cube means here the volume also will 5 meter cube, but the radius will change. Radius is being changed, so the volume will be same. So volume equal to pi by 4, what will come? So sorry, this is an area. So volume equal to 4 by 3 pi r cube. So 4 by 3 pi r cube equal to, this is n into 4 by 3 pi r square, means small r square. So this same cancel, pi cancel. So r cube equal to n into r cube. So we need to mention about this r cube. R cube equal to capital R cube into n. So okay, The next thing is now the area has been little changed. So here the area is means for one, here the area is so much bigger, here the area is so much lesser, so much small. So change of area. We just comparing one big molecule with respect to one small molecule. So change of area equal to area 1 minus of area 2. So what is the area 1? So means this one, okay, this one you can just take n into 4 pi r square. So 4 pi r square, and next one is minus of 4 pi capital R square. So now what will come? So n will come outside and 4 pi 4 pi will come outside and n r square minus of capital of r square. So here as we are r cube, so what we will just move, so here r cube is there and here r square is means, so we have to just multiply into inside. So r equal to r cube divided by n the whole power 1 by 3. So r equal to r divided by n 3. It's okay. So 1 by 3, 1 by 3. So here what will come? Equal to 4 pi n this r divided by n 1 by 3 the whole square divided by r square. So 4 pi n r square divided by n 2 by 3 minus of r square. So now we just take the r square, it means capital R square, 4 pi. If you just take the r square outside, means what will come? R square 1 by n 2 by 3 minus of n. Okay, I think you are getting the point. So we just take this kind of thing in outside way. So see, sometimes you will have different little bit of confusion upon this. So this, see, this is a whole thing. So this also you will the whole thing. So n into r square, this is n divided by n 2 by 3. So you just make this in upward. So n 1, it means dot n 2 minus 3 r square. So what will come? 1 minus 2 by 3 equal to 3 minus 2 by 3. So equal to 1 by 3. So r square dot n, what will come? 1 by 3. 1 by 3. So that's why this kind of thing comes in upward. So I'll just write down the down formula. So del change of area equal to n. Okay. So change of area equal to 4 pi r square 1 n 1 by 3 minus of 1. Okay. This is the formula of change of area square for n number of the droplets has been changed. So what is the formula of work? Work equal to surface tension into of change of area. So surface tension equal to 4 pi r square n 1 by 3. So capital R square, capital R square 1 by 3 minus of 1. Okay. This is the formula. Suppose if in the gate gives of in the gate question or indicator of the question is sigma is given, just directly mention here. And if indicator of R thing or the indicator of remaining other thing is given here, you can just integrate or you can add. So if surface tension, it means energy is given, means how you can just integrate. So if we have a combination, so this thing it means surface tension equal to energy, surface tension energy divided by what? Area. So how we can just integrate? If W equal to, it means you can see, it means energy divided by area to 4 pi r square n 1 by 3 minus of 1. Okay. Or suppose it means as I just mentioned about this kind of, it means you can see as I mentioned about this kind of two things is so much similar to each other. So that's why we will also mention here. It means change of surface tension, it means surface energy for energy equal to work. Okay. So you can just literally make this into each and everything in a very easy way. So you can see work, it means del E of S equal to work done. So del E of S equal to this thing, entire thing, sigma 4 pi or capital square n 1 by 3 minus of 1. Okay. This question has been previously asked in the ISRO exams, ISRO's DRDO game. So you need to just it means remember this one. So I think so you are getting my point. So you can just go to the next one without wasting time. So if you have any confusion also, you just ask in the doubt section or in the comment section. I'll just definitely clarify it. So next thing is the concept of wetting and non-wetting liquid. Wetting and non-wetting liquids. So you can wetting and it's really, if it's shown in the real good an example means it will be a good thing, but image, okay. I think so. Now they are not giving a gooder image, but okay. Anyways, suppose you wetting and non-wetting means you can see here, guys. This wetting and non-wetting comes under the category of cohesion. So you can see in this liquid molecule inside, lot of cohesion is being placed between the water molecule. But water as well as the surface or as well as the air is comes under category means the addition comes into the role play. So you can see here in this, you can see here has been changed to entirely a dome shape. So here it comes under the category of wetting fluid. But if the fluid remains as it is, means it comes under the category of non-wetting fluid. Okay, here the coefficient means the internal bond is so much higher when compared to the addition, uniquely compared to the addition of the sticking of this molecule with the surface thing. So you can see here, guys, for non-wetting liquid, mercury is a good example of non-wetting liquid. Mercury. So you can see here, guys, this is a perfect example of non-wetting liquid. So how the liquid is, it means how the mercury is being dropped. So it means you can see here it doesn't stick to the other surface. Wow, see the beautiful silver. So it doesn't stick to the outer surface. So but you just take the water drop, so you see, guys, so how the water is there. So this is the water. So you can see how it means, see the entire thing has been so much spherical, so much it has been attached. So see here how this is there and how this is there. So this is kind of wetting fluid. So one water comes in the category of wetting fluid, but each and everything we have to see, water and glass, mercury and silver. So a liquid will be wetting liquid for a solid surface if the addition between liquid and solid molecules is more. So you can see more than cohesion. It means this is the formula. So water, glass, mercury, copper, mercury, silver, mercury, gold. Wait one sec. Okay, so this kind of category comes under the wetting fluid. So next is non-wetting fluid. Then a liquid will be a non-wetting fluid for a surface if the cohesion between the liquid molecule is so much higher than the addition. So mercury and glass, means water in a special leaves, water in leaves, and mercury in human skin. So like that. Wait, I'll just close the door. So next one is angle of contact. So you can see here, guys, here as a wetting fluid, the angle of contact is less than 90. So it is called as acute angle. But you can see here, guys, the angle of contact is more than 90. See, this is kind of non-wetting liquid. It comes under the category of obtuse angle. So acute angle and obtuse angle. So angle greater than 90. Here for acute angle less than 90. So okay, these are getting the point. So you can see, guys, water is a non-wetting liquid, but we have to see in each and every case scenario water to where it is interacting. If the water goes and interact with the glass, it's come to the category of other. It means other category. It comes to the category of wetting liquid. If the water comes in the special, it means wait, I'll just water as non-wetting. It's not been given here, but when we just put in a certain kind of fluids or certain kind of leaf, water behaves as a non-wetting fluid. So I think we're getting the point. So you can see here, when the mercury is being interact with the copper, silver and gold, it becomes as a wetting fluid. So okay. So that's the case of scenario. I think so we can just directly go to the problem, and after that we can have a discussion section of each and everything. So the next thing we can just directly go to the problem. So for you can see here, for dimension unit of surface tension, what is the surface tension? Surface tension equal to force per unit length. So what is the force Newton? Here the meter will be. So for Newton, how we can just convert? So it's, guys, it is so much simple. You just no need to think so much higher and higher. So for Newton, what is that? For weight equal to Newton, weight equal to mass per gravity. So weight kg into meter per second square. So you just can make it each and everything. So surface tension equal to kg meter divided by second square divided by meter. So meter will cancel, and what will be kg per second square. So what is the value? M t power minus 2. Okay, this is a value of simple only. Okay. So suppose if in other kind of thing, if you go means this is the thing, but for okay, Newton per meter, it can be also known as Joule meter per meter. So Joule meter square. Okay. So here we have to just convert the Joule into any other kind of unit. So later on we can just proceed. Joule we have to convert into kg and seconds per, like that we have to convert and make into the dimensional formula. Next thing is the unit of surface tension is Joule per meter square. Okay, or Newton per meter will be Joule per. Okay. Next thing is you can see the surface tension is due to what will come, viscous force, cohesion, adhesion, and the difference between adhesion and cohesion. What will come? Cohesion. So cohesion plus interface. Okay, interface of air and the, it means what liquid you are taking. Air and the liquid we take. Suppose if it is water, means water as a interacted with the air. So interface of the air and water. So adhesion must not become. Okay, the adhesion should not become. So adhesion, suppose if we indicate about the adhesion means there the wetting fluid and non-wetting fluid, if it is given here the wetting fluid and the non-wetting fluid is due to, either if they ask me the difference between adhesion and the cohesion, that will come. Okay, in case of surface tension, only cohesion and the interface of the air and water will come. So this is just a normal basic thing, you can just make it out. So the next thing is you can see here. So what they are asking, the required minimum. This is a other case of scenario. Just see, okay, we can just go to the list with this question. A vertical clean glass tube of uniform bore diameter as piezometer. Piezometer will just piezometer means little bit of measuring tube. It will be to be measure the this is used to measure the pressure, and the liquid has a specific weight. Liquid specific weight equal to 15 kilonewton per meter cube. Surface tension equal to 0.06 newton per meter cube. Is in contact with the air. Okay. If the liquid and the angle of contact, angle of contact with the glass is 0. Okay, the theta is literally 0. So angle of contact is another, and the capillary release of the tube, capillary release is equal to 0.2 millimeter. So what is the D? So what is the D required? So equal to 4 sigma cos theta divided rho G. Okay, guys, this is the other formula. Okay, let us go to the next one. So from there only you can have this clear understanding. So they have just asked the formula of this one. So this one they have asked. So we can just see this one, and this one you can just see a small bubble of one fluid immersed in the other fluid as specifically. This one is yes. This one is also correct thing. The droplet of fluid moves upwards and downwards in the other fluid due to okay, yes, this is also correct because it moves due to the unbalanced. Okay, droplet of bubbles attracted by the solid surface can remain stationary if the surface is etc. Yes, this is also correct. If the surface exceeds the boundary force, it also comes in attractive. The surface tension of the bubble is okay. Yes. The surface tension of the bubble is proportional to the radius, and while the boundary force is proportional to the cube. Okay. This one I'll just give another way. Suppose surface tension equal to what will come? Force per unit length. So here the length doesn't comes. So what we will just think. Next formula is Pg divided by 4 sigma d, or for liquid jet 2 sigma by d, and for soap bubble 8 sigma by d into Pg. So we can see d will come here, 8 sigma equal to d into rho Pg. So what is the value of d? It means the d is 2 times of radius. So sigma directly proportional to radius. Okay. So this is the thing. So boundary force is proportional to cube of radius. I'll just tell in the other video. It means in the third chapter this one will come. So work done to change the surface I just mentioned. Work done equal to what will come? 4 pi r cube n r cube or r square n1 minus 3 w. Okay, this is sigma. Or the w can be also written as surface energy. Change of surface energy. Okay, change of surface energy, not surface energy. Change of surface energy. Del of surface energy. Okay. The next thing, white tops are spherical. I just told to you. And the next thing I just mentioned about this kind of things, and these are the other kind of things that has been asked. Okay, we can just see this picture. So you can see, guys, there is the surface tension is war and atom. It means war and air interface sigma equal to 0.73 newton per meter. The Pg equal to what? So diameter is being given 1 millimeter. So we can see here, guys, here newton per meter is given. As you are able to see, I'll just leave the zoom. Okay, here's the newton. My camera. okay, Newton per meter is given, here the millimeter is given, so here is given water and air interface, so what will come? So Pg equal to 4 sigma by T, so 4 into sigma 0.073 Newton per meter divided by diameter 1 into 10 power minus 3 meter, and what are, sorry sir, so this meter will come down, so meter cube will come, so Newton per meter cube, so you just multiply and put the answer. So next thing is you can see about the soap bubble. What is the formula of soap bubble? Pg equal to 2 sigma by D, so you can see, oh sorry 8 sigma by D, 8 sigma by D. So atmospheric pressure, if the diameter is being given, surface tension is equal to 0.1 Newton per meter, and the diameter is given 2 centimeter, so 2 into 10 power minus 2 meter. Okay, so now you can just calculate the next thing, and you can see guys, the next in 2014 has been given the difference of pressure, and it comes around the air bubble of diameter immersed in a surface tension immersed in a water. Okay, so what is the value? So it will be equal to 4 sigma by D, equal to 0.4 into 0.070 Newton per meter divided by D, 0.001 meter. So what is the value? So 20,042 come on 72. Okay, oh, here literally they are just mentioned like this way. In other format they are just mentioned, so you don't need to couple. So air bubble is immersed around it, so only one surface is in contact with the air. Okay, so literally this also comes under the same thing. Okay, the next thing you can see, at the interface of liquid and gas at rest, the pressure is higher inside the concave and lesser inside the compared to the concave. So first one is, so here this won't be, this won't be. Okay, so for wetting fluid theta less than 90, and for non-wetting fluid theta greater than 90. So this is the criteria. You can see guys, the mercury is like this, and the water is like this, and mercury is this. So before I just showed you an example. So this is not. I think so. At the time of the blood and that has been shown. I think so. I'm not able to getting it. See this one. See, this is blood, and how the blood comes up like this. But you can see the mercury comes up like this. So you just place the pins. So this is a steel, so you can see it can conduct easily. So I'm just holding the steel here. So why? My hand has a certain amount of heat and a certain amount of electron. So that's why this kind of electron is being transferred in this kind of steel. So that's why this is moving. So literally see guys, I'm not touching any kind of, but literally with the hand. So okay, I would say take the pen. This is a plastic. No amount of electron is being transferred, or no amount of heat is being transferred to this pen. This is plastic, but you just see this is a steel. So it has an easy amount of transfer of electrons. So you can see. Oh my god, for me now bulb coming. See, so now it's able to move. Okay. So this is a small thing. See, now it's moving. Okay. Oh, sorry. It's just back. Come to the point. So this is the water. So water is like this, and as you can see, the water is like this, and the mercury is like this, a little bit upward or downward like that. So next one we are just going to see about the capillarity. C-A-P-I-L-L-A-R-I-T, capillarity. So a capillarity means you can see here guys, sometimes the fluid may rise, sometimes the fluid may decrease. It's also due to depend on the capillarity. So now you can see here guys, here the concave meniscus and the convex meniscus are the kind of thing. Here it will be like this, and here it will be in a convex even downward circle. So this all occurs due to the capillarity. So the capillarity rise, it means a general term for phenomena is liquid to the intermolecular attraction of the liquid boundaries. So I think so. I just lost my blue pen. I couldn't find the blue pen. You can see here it means here just a pipe, and here the water molecules will be like this, but for mercury the water will be like this. So the water usually have a good contact with the glass, so that's why it has been posed like this. And since the force is upward, and the weight of the water also will force around it. So like this, you just like this, like this, and the downward will be the weight of the water. So this both of the thing will match to each other. It means upward force equal to weight of the water. So while we just match in each area in everything, so we used to conclude. So the direct formula you can see. So the lateral formula is this one. So this is the height and this is the weight of the water. We have to just consider. So H equal to 4 sigma cos theta divided by rho gt. Okay. See for this one, if you just capillarity see this is a little bit of kind of thing. This kind of always comes under capillarity. Okay, I think so getting them catching the point so much easily. So you can see how the each and everything depends on the it means their diameter. So you can see guys, literally here diameter so much, so it means as you go like this the diameter start to decrease. So as the diameter start to decrease means the height tends to increase. So you can see in each, but all the fluid will be, it means theta will be same, but as the diameter decreases the height also increases. You can see as it linearly increases due to the diameter. So H equal to 4 sigma cos theta divided by rho GD. So density same, gravity same. For each and everything you can see the density same, gravity same, sigma same, all kind of liquid is same. But the theta is also same. This height directly proportional, inversely proportional 1 by d. So in this also they will ask little bit of questions. It's just a small basic examination. So as I just told you, it means before, you can see here the upward surface tension force. The upward surface tension force is equal to weight of the fluid. So what is the upward surface tension force? Means this thing I think so not needed. Okay, upward surface tension sigma d. It is here it's been given in the formula of sigma d, sigma of cos theta. So why this cos theta is given? Because you can see this thing means if this one theta. So okay, as this theta is being mentioned, that's why we are just mentioning theta and equal to weight. So weight equal to weight is mass into what will come, gravity. So for mass what will come? So density equal to mass by volume. So volume equal to volume into density equal to mass. So for density into volume, what can area into height equal to mass. So this one will just pi d sigma cos theta equal to mass means density into area into height into gravity. So this one how we are saying is sigma equal to force per area. So what is the unit of force? Force equal to sigma into area. So this is the area, it means this is the circumference. So pi into d into, I think so you are catching the point. So this one, so it means this is length, length. So length equal to pi d. So while you are just making aligning of each other, this height will just take height. Here the height is here. Okay. I will just put and we'll just the value from. So you can see here guys, the other thing, if the angle of contact of the drop is acute, it means what is the between of acute and obtuse. So acute means how much I just told about. Acute means less than 90. It means less than 90. So obtuse means more than 90. So you can see here guys, what is this? We can just show here so you can have a good understanding. See, acute is less than 90 and here acute is more than 90. So in this one, which one will come? So if the angle of contact of the drop of liquid is acute means less than 90 means, so which angle will come to you? You just think and you just make an answer. So this thing like this and here 90. So here what will come? The adhesion is more than coefficient. So okay, the adhesion is more than coefficient. That's one. The it means the liquid droplet will be acute. So if it is an obtuse means the coefficient is more than adhesion will come. Okay, we can just go to the direct formula. So now we can just go to the end of the story. That's it. So the capillarity lies is inversely proportional to the diameter of the. So thinner the tube, the greater the height. Okay, this one I just showed the example. Capillarity effect for the surely negligible is more. Okay, this one is not here. The capillarity rise is inversely proportional to the density of the liquid. Okay, this height inversely proportional to density, height inversely proportional to the diameter. And see guys, the surface tension is due to the cohesion between the particles of the surface, and capillarity rise is due to capillarity raised is due to adhesion as well as cohesion. Okay, so these are the other things. This one you can also just slightly make it up. And see guys, this one is also one of the interesting. When the capillary raise is a narrow two-dimensional slit of it means here it's not that much clear. Okay, what is the capillary rise? What is the capillary rise in a narrow two-dimensional slit of W? So two-dimensional slit. So this is the answer. Half of the capillary, two of the diameter W. This one not mostly needed. Okay, next thing you can. So remaining things mostly the same thing will come. So you can see here whenever the each and every formula is being given, you just directly put in and you just solve the each and every answer. So I think so we are getting the part. Okay guys, that's it. We just completed the first unit and it means first chapter, and from next we will go to the second one. Okay, let me see you in the next video and have a good day. Bye bye.